So good afternoon. This is an overview of the activities of the ADA Center for the past year. The ADA Center started in 2018 and we reach right now the midpoint of the lifespan of the center. The center set out in 2018 to reignite computing system innovation. As you may remember from my prior presentations, those of you who were with us, the key challenges we face today are those of diminishing value from transistor scaling, skyrocketing design complexity, and unmet application demands. To address them, we propose to investigate research solutions that enable sustained scalability in system functionality. If we cannot extract value from scaling, we propose to investigate opportunities in architecture, new type of devices, and lowering manufacturing costs. We also believe that impactful innovation comes from broad participation in the technology playground. To this end, we are set to investigate design flows that are faster and accessible, meaning we want them to be accessible by a larger population of engineers who are not as extremely specialized as the one we have today involved in hardware design. So as a result of this, our work is organized along 3 research vectors: designs, architectures, and technology, as you can see in the belly of the rocket in here. So in a nutshell, I can tell you just one slide what we accomplished in the last year. And actually in the last 2.5 years, some of it. On the design front, which is now called the DEF development theme, as per request by other sponsors, our goal is to develop complete design flow that go from DSL to hardware. To date, or better, in the beginning of the center, we really focus on develop engine blocks, new DSLs, new intermediate representations. In the past year, we really moved from engine to stubs of the design flow, segments of the design flow. On the architecture front, we started with a few accelerators at the beginning of the center, especially in the neural network domain. And we have now expanded to a broad set of accelerators. On the technology front, we are exploring chiplet-based design frameworks to address manufacturing costs, fast design-to-chip frameworks, and we're also evaluating emerging type of storage devices, also in collaboration with the Ascent Center. Finally, our benchmark effort has already produced a healthy set of benchmark suites. In the past year, we have released a suite of XR benchmark, meaning augmented and extended reality benchmarks, post-neural network machine learning, and both parametric benchmarks for neural networks and end-to-end suites. So our ultimate vision is to be able to develop an ecosystem for application enablement where it's easy for designers and developers to design and utilize new silicon. This is the ADA design flow framework that I presented last year. And as you can see, we have a full flow from domain-specific languages on the left, all the way to hardware implementations on the right. Everything with the red border is something that has been developed as part of ADA. And by any means, there are many other domain-specific languages, many other intermediate representations that other people in the research community has developed. What you see in the middle section are intermediate representation, which is a multi-layer substrate with the left side facing the high-level language and the right side, so focusing, for instance, on extracting parallelism, and on the right side, be more target focused. What we did in the past year is we went beyond developing the stubs and the engines of the design flow framework and started to develop segments that cover that. So for instance, Relay started working with the VTA to target FPGAs. Dahlia was able to map directly to hardware. Taco was able to map, instead of C and C++, directly to a CPU compiler target. Similar for Graphite, and PyMetal and Mamba mapping directly to hardware. So while we don't have the complete design flow, we now have segments that go across the design flow. In addition to that, we have developed a number of core compilation improvements. For instance, we have developed a new scheduler for Taco that can improve the performance of the compilation targets. We have been working on extracting parallelism and also on representations from tensor that can leverage both efficiency and being compact. On the second research vector, the one of new accelerator domains, as I said, we expanded our offering compared to last year. We have now accelerator architecture that are enhanced to support privacy aspects. we developed a number of accelerators for graphs. And the team at Harvard taped out and produced a natural language processing processor accelerator. Specifically, this design took 11 months from the beginning of the development to a chip working in the lab. And that 11 months includes 5 months of waiting from the fab. It was developed using an HLS, and it shows the efficiency of the type of approach. Ritu Das worked on developing accelerator for genomics. Wainish developed Jigsaw, which is a 3D image reconstruction for MRIs, which can also be applied to other fields like astronomy or other variants of radars. And the accelerator accelerates the grading step of MRI image, which takes over 90% of the computation time when you process MRIs. And finally, Brooks and Wei worked on a distributed accelerator for machine learning privacy, where they leverage both the edge and the cloud to do computation in the cloud while maintaining privacy of the data. On the technology front, we have seen the tape out of a chip that Dennis Sylvester presented last year. It wasn't taped out yet, it was still in process. Now the chip has been back, is tested, is published. It's a 22 nanometer neural network, very low power, that stores all the weights on chip, specifically stores it in ReRAM storage in a compressed form, and then transfer it to SRAM for the execution. This is the largest chip, so the chip with the highest number of on-chip stored weights. Mike Taylor continues developing on the base jump framework, specifically developing a base jump socket, which sets parameters for the physical, the link layer, and the MAC layer. If you can go to the website and see the demo of these projects, you can simply drop the accelerator in the socket and it can work with the rest of the platform. And then finally, the Harvard team is working with Michael Niemeyer on evaluating non-volatile storage devices at the system level. This project actually will be presented tomorrow directly by Mike Niemeyer. This is a collaboration between Ada and Ascent. Finally, the development of benchmark is not only something we do to support our research, but it's also our deliverable for the JUMP program. What we strive to do with our benchmark is to develop benchmark that drive the design of computing system for the 2030-2040 decade. So we organize our offering to cover what we thought were the key applications domains and the key platform that we foresee will become critical and predominant for the next 2 decades. So far, we developed the suites that you see on the left side, the one with the darker blue, and we are also planning to develop before the end of the center, the suites on the right that have a dash border. We try to target the critical application, as I see, so we have coverage on augmented and virtual reality, on media processing, on machine learning, both neural network and beyond neural network. Indeed, we are pushing growth in benchmarks on the beyond neural network space. And then on graph-based algorithms and privacy aspects. In terms of platforms, we're trying to focus on edge type of computing, data center, and then also go from kernel to end-to-end application and IoT type of communication patterns. One thing we did late last year is to create a collection of the benchmark suite that are available to the community. And so if you go to that website at the bottom, benchmarksuites.adacenter.org, you will find all the benchmark suites that have been developed and released by Ada, all the benchmark suites that have been developed by other JUMP centers, and also the suites that are contributed by the research community. Because we want to take a look at the whole offering and cover potential holes rather than duplicating efforts. So we want to have everything together to make sure that what we offer is a good addition to what's available already in the general community. One last thing, if you look at the diagram in this slide, the bottom right corner is a number of benchmarks that have been offered to date in that suite. And that's a growing number. We launched a suite and then we continue to grow it throughout the years. In addition to this benchmark goal that, as I said, is our deliverable, we also are striving to develop an additional, or to deliver an additional goal, which is a complete design flow from a high-level domain-specific language all the way to a heterogeneous system with accelerators, to a system who can run the same application in an accelerated fashion. To do so, this January, we launched 3 projects in this space. So 3 projects that are proposing to develop complete design flow from DSL to hardware. And the goal is we're going to invest in 3 directions in the hope or to gain significant confidence that at least one of these efforts will be successful. So the 3 projects are from Graphite to the Omega Accelerator, from Relay to the Flex NLP, leveraging the ILA project that you have heard for the past 2 years about, and from Tiramisu to the Flex NLP Accelerator. This is a summary of the goals that we set for ourselves a year ago. And it's a summary also of what I discussed so far. So on the benchmark effort, we increased the type of offering to target the needs for the 2030-2040 decade. On the accelerator diversity, we have been enriching the domains that our accelerators target. We've been extending the science of domain-specific languages, enable fast iteration design flow, both in terms of design flow and also in terms of implementation and fast idea to hardware processing. And then on the technology, we've been developing models for new technology and devices. In addition to the core research, we've been doing some other activities in this center. First of all, I would like to mention the hackathon we held last October. We had over 70 participant ADA students who came together and worked for a day on a domain-specific language. Specifically, they were working on Relay, and the project was facilitated by Zach Tatlock together with students both from CRISP and ADA. And so some students added a new feature to the domain-specific language. Some students worked on the compiler side. Some other students worked on the intermediate representation. The goal of the effort was to make the entire ADA community aware and practically able to work with DSLs. To complement that, in the prior 2 years, well, in the prior year, actually, we brought students together 2 other times for hackathon. During our second hackathon, all the students came together and they learned how to map a software application to an FPGA. We give them a different project to map different applications. And then earlier on in 2018, they also worked together on benchmark developments. So they really got to appreciate the importance of having benchmarks and the value of distributing benchmarks. In terms of other highlights of the center work, last year, the number of students in the center grew from 90 to 131. Part of the reason is our PI composition, as I will address in a second. I would also like to point out that we have a student database. It's available on the symposium website for everyone. And that is being updated this month. So it's currently up to date, it's very fresh, where you can find a profile for every student that is part of the ADA Center. We had 4 e-workshops like every other center did, but the presenters in our e-workshop last year were senior students of ADA. They went very well, and so we use the same approach this year in appointing senior students and senior student presenters to facilitate the e-workshops. We also led 135 liaison meetings to date. The last one was last week. They're all on Wednesday, as you probably know by now. Tanvir had 25 participants last Wednesday at his liaison meeting. And then we've seen a growing collaboration between PIs and sponsor, which have matured to the point where we start seeing publications that are joint between PI and sponsor. And this is just a sampler of some of those publications. We've done a number of projects to engage the broader research community into the research agenda of ADA and creating an awareness of the type of work we do. So in February, we had a jump-wide workshops on benchmarks that each center offer or may need. We hosted a workshop at DAC on near and in-memory computing. In August, we had another jump workshop on domain-specific languages. And also in August, we met at DARPA to do a visioning exercise for how technology is going to look in 2040. I personally had a lot of fun during that meeting at DARPA. And then in December, we released this site that has a collection of the benchmark suite developed by the center. I would like to highlight a few accomplishments also by our team members. These are students who won awards. It's a sampler of the students who won awards. We have many more. Radha was invited to the Rising Star Workshop last year. Kevin, Andrew, and Sam won an NSF Graduate Fellowship. Andrew and Abram won a Towner Prize in Engineering. And Abdullah Ram was invited to the Heidelberg Laureate Forum, which is a workshop where they invite PhD students to spend a few days together with a large group of Nobel laureates. And these are recognition by our PIs. Tim and Barish won the NSF Career Award. Please don't tell anyone about Barish, it's not official yet. Todd and Dennis became college professors, Saman became an ACM fellow, and Sarita and Margaret were elected to the American Academy of Arts and Sciences. A number of our students graduated and joined a sponsor company or a university. So here you can see how a number of our students became academics, which I believe is a good thing because their students will be students in JAM 2.0, and the others join some of our sponsors directly. We also had one PI transfer to a sponsor. Margaret joined the National Science Foundation in the role of director for the Computer and Information Science and Engineering Directorate. In that role, she sponsors and guides the research of all of NSF in the domains of computer science and computer engineering. And she is responsible for about 1/7 of the entire NSF budget. So as a makeup for that, we also had a few additions to the research center during the last summer. Ada Gavrilowska from Georgia Tech, Tim Rogers from Purdue, and Ritu Das from the University of Michigan. Those of you who joined us for the Symposium 2019 last spring had an opportunity to meet them in person. They were with us to learn more about the ADA back then and then join us later in the summer. So this is a full slate of our PI as it stands today. Finally, I would like to tell you a little bit about our student internships. These are the students who went already on an internship with a sponsor. They already completed their internships. We have a number who are about to go in the summer of 2020. A few of these students have internships that were later canceled in the recent months by the organizing company due to the ongoing situation. And so if you go and consult the ADA Center database, you're going to find them available again, and you may be able to recruit them now. So in summary, this is what we would like to accomplish in the next year. We would like to grow our coverage in benchmark for privacy application, end-to-end, particularly multi-party XR and graphs. We would like to explore the free design, complete design flows that I highlighted earlier. And we would like to start thinking in a more organized way about productivity metrics. I already mentioned a little bit how the Flex NLP design went, but we would like to have a more broader spectrum of metrics that fit the type of work that we're doing. And then we are planning to develop solutions to better support the DSL ecosystem, how to develop DSL, how to make sure that the compilation step is correct, how to make people productive when they develop with these new domain languages, domain-specific languages. As I mentioned a little bit earlier on, we launched 9 different seed projects this January. These are seed projects, meaning they are on for 1 year, and we are going to see how they go and decide how to sponsor them longer. 2 are focused on covering spaces in our benchmark offering that we think should be stronger. 3 projects are those domain-specific language to hardware complete flow that I was mentioning earlier on. And then other 4 of these projects are core research for ADA. So for instance, Hammerblade plus Spandex works on putting together the Hammerblade hardware platform with the Spandex interface protocols to be adaptive and efficient in managing multiple accelerators. HEAL is an encrypted arithmetic library that not only develops a library of hardware components, but in the process also evaluate generating languages. And for instance, the RI project explore how to leverage machine learning to generate compilers from DSLs. This is a little summary of the feedback we received last year by the SAB. On the front of contextualizing ADA research, we've been meeting to discuss our benchmark offering and organize it in a way that cover all the domains that we think are critical for the next 2 decades and the platforms. We're pushing free distinct DSL to hardware flows to give completeness and cohesiveness to our design flow framework. And then even if it's not a direct mandate, we're really taking time and dedicated time to onboard our student community into a research community of high-level design experts. people who understand the entire spectrum from domain-specific language to hardware and can work throughout all the steps. On the benchmarking front, we have been increasing the breadth of our offering, identifying key domains and key platform, and release the collection of suites through the website that I point out there. We've been expanding our novel architecture offering as suggested by the SAB2. And then we dedicated a bunch of effort in sharing our learning across JAMP through the workshops that we organized, through tracking our collaborative effort, and through discussing benchmark needs and benchmark offering with the other centers. Finally, clear ADA communication and increased collaborations. We try to develop much more media about the activities that we do. And if you go to the symposium website, you should find already videos for our seed project and for our demos. So this is our quick agenda for the rest of the week. Soon after me, David will present what has happened outside of ADA and our awareness about it and our assessment about it. Tomorrow, we'll spend our time, morning and afternoon, hearing about overviews from each of the themes in the center. And for each theme, we're going to also have a dedicated discussion about one project in that theme. At the end of the morning, we're going to see all the pictures of the demo projects that students have developed with 26 demos. And then in the afternoon, there is an opportunity for the sponsor and all the participants of the symposium to go into individual discussions room with all the students that develop demos to have discussion about their own demos. Later in the evening, we're also going to explore a virtual happy hour. That's at 5 to 6 p.m. That's a relatively new tool that we are exploring. And I don't know how much it scales to the number of people in this event. So I would recommend you bring your own cocktail and drink throughout. So let me talk a little bit about those asterisks. Most sessions in this conference are plenary. And to connect to the session, you can use exactly the same link you used today with exactly the same password. However, we have sessions that are concurrent. These are the demo sessions where the students present their demos and discuss their demos. We have student presenters who are going to have individual student sessions. We have PI chat rooms, and we have seed project discussion room. All of these happen to take place in a concurrent setting. If you want to access and discuss with any PI or any team or any student, you need to go to the symposium2020.adacenter.org to grab the link of the session you want. So you go into the proper website, to the proper page, I'm going to show you in a second, and choose which presenter and team you wish to speak to. If you're a WebEx scholar, since we only received one account from the WebEx from SRC, you can coordinate with Fitsum, who's always on the WebEx line, and he can help you go as a group from session to session and move around to discuss with the people you want. So these are all snapshots of our 26 demos that you can find on the student demos buttons on the symposium website. Wednesday morning, we're going to have an industry session followed by the Lynn Conway Student Research Award. We're going to give an award to the 2 best demos. Todd Yunke is a coordinator of the evaluating committee, the review committee. So his committee will be able to identify which are the 2 best demo videos. And the presenter of the award would be Lynn Conway herself. In the afternoon, we're going to hear student presentations. They're going to be 4 and 4. And then we're going to have this concurrent session where the students can meet with anybody who want to talk to them. Thursday morning, our PI will discuss some of their experiences in research that had not worked as well as they hoped and why and what they learned in that process. I will then talk about the KPIs for the sponsors, and we're going to go into individual chat room for individual PIs. And then we will spend Thursday afternoon to discuss collaborative seed projects. These 9 projects that I outlined that we started this past January. I would like to remind everyone that the next time we get together is going to be mid-October. I would like you to block all those 4 days. If we get to meet in person, it will probably be just a day and a half or 2, but I don't know how things will pan out. So we are trying to reserve the whole week so we have flexibility in what we do. And we would like to thank our sponsors and the JUMP program for the opportunity to bring everyone together today and do the research that we do. So now I will, first of all, allow you to take a quick look to the website for the center. So you can go to this website by clicking symposium2020.etacenter.org, and you can click on the buttons to see all the student demos and the link to go chat to the student during the proper time, all the seed projects, and our directory of all the students, which you can see by scrolling there. And then when you are on the main event homepage, you can click on the window at the time where you're at to get details about what's happening in that session. So I just would like everyone to make sure they can access that site because it will be convenient in getting all the extra information. So thank you so much so far, and I'll pass the presenting view to David.
Good afternoon, everyone. So I'm going to spend a few minutes now talking about beyond data, how the world has changed. When we did this last year, in retrospect, it seems quite quaint. We were talking about things like DNN hardware becoming commercially available in the sense that TPUs were available for cloud access from Google, and RRAMs were becoming commercially available from Foundry companies to be integrated with conventional CMOS techniques. There were some interesting things in the policy and government side with respect to the ERI launch, the AI executive order. So quite a lot of new funding has been invested in electronics and AI over the past couple of years due to these initiatives. And there was also quite a lot of interest in new privacy rules, particularly coming out of Europe with the GDPR announcements that have caused some of the large internet services companies to emphasize privacy substantially more. And that has actually led to some increased interest in how to support this from a technology point of view. Obviously, when we think about how the world has changed this year, it's quite a bit different. There's one thing that's on everyone's mind, which is this COVID disaster. And I want to take a few minutes today to talk a little bit about the computing challenges of COVID. So there's been an enormous interest in research in this space. And I've just highlighted a couple projects that I've seen that are at least somewhat linked to the JUMP initiatives in both data and beyond. The one on the left here is talking about the epidemiology analysis of COVID, how we can use machine learning techniques to try to make predictions about disease spread. This is obviously quite challenging, especially when there's a lack of data. So many of the conventional machine learning techniques based on deep neural networks don't really work. But it is a great example of where some of the beyond DNN techniques built around probabilistic AI, particular Bayesian inference, can have an opportunity to shine. So the example that I'm linking here is a study that looked at constructing causal models of disease spread based on parameters of things like the amount, type, and accuracy of testing strategies, combined with things like death reporting policies that are being used in order to make projections about the population of COVID survivors, those that will have symptoms and won't and whatnot. What's interesting about these models is that as we try to gather data from different regions, it becomes very clear that you can't just use data from one country's experience and apply it to another country or region, because all of the different strategies differ quite a lot. We have the problem of both unobservable data as well as data that you have to make inferences about because the data is either incomplete or collected in a very different way. So these causal models combined with Bayesian inference have been shown to be able to try to make better projections. And I think it's quite interesting to see that these techniques are starting to win out in some of the strategies that are being used going forward. On the right, we see something that's a little bit more classical high performance computing analysis. So what this linked article talks about is the global sprint to try to find therapeutics and vaccine candidates for COVID using the world's fastest supercomputers. So all of the power of those supercomputers have been kind of coalesced together in this COVID high performance computing consortium that I think IBM Research had a big part to play in developing that. It's quite interesting because many of these strategies for finding new drugs are built around trying to find protein structures of the disease. So in this case, as the protein structure of COVID became more well understood, various potential molecular compounds could be analyzed and screened against those protein structures. So something like 8,000 compounds exist, and they found that 77 molecules could potentially disarm the virus. And then what they're working on using these large supercomputers is just crunching through the various combinations of those molecules that could come up with the best drugs to try to target COVID. I find this project particularly interesting because it really aligns well with one of the CRISP grand challenges. In the CRISP Center, trying to do computing for automatic drug discovery is one of the grand challenges. So it does align quite nicely with the JUMP overall. Let me talk about one project that's particularly linked into Ada work, which is another scientific challenge, and that is the testing problem. So as we want to be able to find who has COVID or has had it in the past, there becomes a need for rapid genetic sequencing to be able to look at the DNA or RNA extraction from these tests and then compare it to what they expect to find for SARS-CoV-2 DNA and RNA sequences. So there's a project that Ritu Das has been working on for the last couple of years in the bioinformatics space, which is essentially building accelerators for sequence analysis. So in this work, there are quite a lot of direct tie-ins between Ritu's work on building accelerators for sequence analysis and rapid COVID testing. So the goal is to be able to build a real-time portable low latency tester to be able to take the specimens and directly at site be able to decide whether the specimen has COVID RNA or DNA in it. And this can be done using these accelerators because normally that kind of analysis of being able to explore the large set of sequences that are needed to perform this analysis could take many hours or days, even on large supercomputers. So the sequence analysis acceleration can be quite useful in trying to speed this up to something that could be used for a portable real-time test. The group at Michigan has pretty rapidly turned to try to see if they can use it for this specific problem in conjunction with someone in the medical school. I found this to be a really exciting project and really look forward to seeing more successes out of that project. So definitely find some time to talk to Ritu about this because it's very exciting. Beyond the science of COVID, there's also the sociology of how we're starting to interact with each other in different ways because of the work from home isolation. So many companies are realizing that they need to adapt in this environment, and they're actually finding that the future of work may change. Because of this forced experiment and having employees work from home, they're realizing that some things actually have been working pretty well. And there's a lot of advantages to having their employees be able to work from many different locations as opposed to having everyone have to cluster in some of the big high-tech centers around the country. So Twitter, for example, announced that their employees will have the option to work at home more or less indefinitely. And I suspect that other companies will start to follow suit as the technology of providing these remote interactions improves. So for example, even during this Ada meeting, we're going to be trying out several different technologies, the classic Zoom and WebEx, obviously for the slide presentations, but we want to try out some of the newer technologies. So we're trying for the cocktail hour tomorrow, this new software that lets you walk around different groups and interact in a way that's much more like a casual meeting. But in the longer term, I think there will be a lot more experimentation and development of these VC remote work strategies. So maybe this will be the opportunity for AR, VR to find its foothold in things that go beyond gaming. And this may result in a much larger uptake and adoption of those technologies. Things like Second Life that have been around for almost 15 years, but still haven't really had their moment, are now starting to see a surge of interest as people realize that they want to find better ways to interact. And obviously there's quite a lot that can be done just within these video chat applications to be able to make it seem like more seamless in the sense that you're working with someone directly. I'm quite gratified to see the work from Illinois that actually directly touches on the virtual reality component here. So Sarita Advai's group has developed the extended reality benchmark suite called Elixir. And I think this is going to be a major help as computer architects start to think about how to target this very challenging, computationally challenging domain of extended reality, virtual reality, extended reality applications. So it also kind of fits in with this goal of trying to make remote interaction much, much better. On Wednesday, we are going to have an open forum where we dive into these questions in more detail, and we encourage everyone to attend this, to share your thoughts about how COVID and Ada are intersecting. And we mean this in the broadest sense. So we're interested in understanding how our Ada research can address the pandemic. We're also interested in understanding best practices for remote work. How have Ada researchers adapted to the remote work environment? One thing that I think has become clear is that inter-university, inter-center collaborations are now on an equal playing field with what used to be a very difficult conversation where before I could talk to my colleague in the same hallway. Now that conversation with that colleague is the same as having a conversation with anyone in the center. So this, in some sense, does even the playing field and make it much easier for us to find collaborations across Ada and across JUMP. Maybe that will have a larger impact going forward. And finally, just thinking about new research opportunities that this evolves. So we hope people to come and share their ideas. With that, I have finished up my presentation, and we're happy to take questions about Valeria's talk or some of the stuff that I just talked about.